All right, guys. All the leg work, all the grunt work's already done. We're sitting at this point where we got the area between two curves. We did the top minus the bottom curve on the other video. We also came up, we ended with, and there's a reason I ended with that particular one in general. Let's see here. Is we ended the last one, I said, watch out, guys. Because when you get something like this, here, when you get something like this, you got to do area 1 plus area 2. And that's going from 0 to 2, and I think this one's 4, something like that. Okay? So then we'd integrate from 0 to 2, we'd integrate the square root of x, and then from 2 to 4, we would integrate square root of x minus the quantity x minus 2. Because we were integrating with respect to x, so our triangles were like this, right? We're just stacking our triangles going this way. Well, there's a little bit of a shortcut, guys. Sort of a shortcut. Gets a little confusing sometimes, but it works. So what if we looked at it a little differently? What if I said, nah, I don't want to do that. I can, because you guys are all superstars, you go, well, wait a sec, can't I make a rectangle this way? And I can make another rectangle this way? Which really means that if I take the area under the curve of the right one and subtract it from the area under the curve of the left one, I'm going to get all the areas from left to right in between of all these triangles. So the difference is, though, we have to integrate it along the y-axis. So I need a y value here, and I need the finishing y value up here. Okay? So I've got to integrate from here to here. So we have to look at this differently now. We have to look at it in terms of x equals y. So we're dealing with respect to y. So right now we say y equals the square root of x. For this particular problem, because we're going left to right, we have to solve for x. And we're going to say x equals y squared. So for this problem, when we're going left to right, this is going to equal y squared. Okay? So it's either the square root of x or it's y squared. But since we're going left to right, that's my new piece. X equals y squared. Then if I'm going here, we have y equals x minus 2 if we're dealing it in respect to x, but now we need it in respect to y, so I'm going to solve for solve for x. I'm going to add 2, I get y plus 2, so that means x equals y plus 2. So this is going to be x equals y plus 2. I no longer need that piece because I'm going to integrate it from the right one minus the left one with respect to y. So I need to find the y values. So how did I find where they intersected? I set them equal to each other. Well, we're going to set y squared equal to y plus 2. Y squared minus y minus 2 equals 0. And if we're looking at this, we get y minus 2, y plus 1. Okay, and that equals 0. Y equals 2. And then y equals 2, and y equals negative 1. All right, so we have two values here. Y equals negative 1 and y equals 2. Which one are we going to use? Well, let's look at it this way. It's 2 or negative 1. Well, we want everything above it, so our value is going to be 2 right here. So our y value is equal to 2. Why is it not -1? Number one, it's not below the y-axis. And people are like, well, how'd you come up with -1? Well, if these x squareds wrap around on themselves, and this would, if it was scaled right, this would be -1 down here. It would cross down here, but since we don't need it, it's not in our valid domain values or range values, we just don't use this -1. This is useless to us. It's dead to us. All right? So we've got this piece. Let's kind of clean all this stuff up. We're going left to right. So in other words, we have to take the right value, which is our bigger equation. If you flip it over, it's kind of like this is the top. So we're going to take the integral of what? The integral from 0 to 2 of the right value, y plus 2, minus the left value, y squared, dy. So now when we take this piece, we're going to take the integral, let's clean this up, 0 to 2, make sure I don't screw this up again, and we're going to do negative y squared plus y plus 2 dy. So then when we integrate that, it's probably getting a little light for you guys. When we integrate that, we're going to get negative y cubed over 3 plus y squared over 2 plus 2y, evaluated from 0 to 2. And then we plug our same pieces in that we had before. We're going to plug in 2 first. So we're going to get negative 8/3 plus 4/2 plus 4. That always ends up in the wrong spot. And so there's that, and I'm going to subtract the lower one, which is going to give us negative 0 over 3 plus 0 over 2 plus 0, which just pretty much shoots all that down. And so we get negative 8/3 plus 2 plus 4, which gives us negative 2 and 2/3 plus 6. So that's going to be 4, 3, 3 1/3, or approximately 3.33 units squared. See if I did my math right real quick. Yes, 3.33 units squared. If they wanted an exact value, you would have 10 over 3 would be an exact value for you guys. Okay? So that's how we deal with areas between two curves. We solve for x, and we use our y values here as our new points, or our new functions. They're functions in relation to y. We set them equal to each other so we can find how we're going to integrate it up the y value or the y-axis. Remember, we're dealing with the y-axis here. And then if we're dealing with the y-axis, we're going to do the right value, the right function minus the left function, and we're going to integrate from 0 to y squared. So we've got a couple of techniques, top minus bottom, or right minus left. But don't forget, when you do right minus left, it's going to take care of the fact that you've got to solve for x. So you've got to do a little bit algebraic manipulation. All right, guys, we'll talk to you later. Good luck. See you soon.